Okay, this is going to be episode 3 in our polar coordinates mini-series. In this video, we are going to focus on converting from polar to rectangular and then rectangular to polar coordinates. So let's start with this question here. We want to convert the point 4, pi over 4, to rectangular coordinates. And remember, every time we start in polar coordinates, we're going to have r and then theta, which means that if I wanted to graph that, I would go to the fourth ring, 1, 2, 3, 4, and then I would go to pi over 4. So this is where that point falls. Now, in order to convert this to rectangular coordinates, I want to know, instead of r and theta, what is x and y? Well, r is like the distance from the origin. Oops, that's not a very straight line. R is the distance from the origin to this point. I'm having a really hard time drawing a straight line right now. So that is R. And we know that R is 4. What if we drew a right triangle? So we've got the vertical component of it, and then we have the horizontal component of it. And we know what this angle is. This angle is pi over 4, or if you like degrees better, that's 45 degrees. And so really, we have this triangle here with a 45-degree angle, or pi over 4. So we could figure out what our vertical component, y, is, and what our horizontal component, x, is, using trig. The sine of pi over 4 is equivalent to my opposite over my hypotenuse, y over 4. Well, if I want to try to get y alone, because I want to know what my vertical component is, I could multiply by 4. So 4 times the sine of pi over 4 equals y. And the sine of pi over 4 is actually just the square root of 2 over 2 because of the unit circle. So I can replace sine of pi over 4 with the square root of 2 over 2. And then it's a matter of simplifying. And so 4 divided by 2 is 2, and so y equals 2 root 2. Now, the x component of this, because it's 45 degree, is very intuitive. Because on a 45, 45, 90 triangle, x and y have to be exactly the same. But let's go ahead and work it out. If we were to do cosine of pi over 4, we'd have x over 4, adjacent over hypotenuse. So cosine of pi over 4 equals x over 4. Now we'd multiply the 4, and we'd have 4 times cosine of pi over 4 equals x. Cosine of pi over 4 from the unit circle is root 2 over 2. And when you simplify that, you get x equals 2 root 2. So this ordered pair in rectangular form is x and then y, so 2 root 2, comma, 2 root 2. And there we have it. So what we did was we drew a right triangle, and then we used our right triangle trig. Now, there are rules for this. There are some common rules that are going to follow us throughout. X is always going to equal r cosine of theta. So if you know r and you know theta, you can always find x. Y is always going to equal r sine of theta. So if you know r and you know theta, you can always find y. Now, a couple of other cool things to know is that r squared, from the Pythagorean theorem, r squared is the same thing as x squared plus y squared. And so if you know x and y, you could figure out r. And then if you know x and y, you could also figure out theta. Theta would equal inverse tangent of y divided by x. So these are some really important formulas. Now, I would like to do one other thing. I would like to just show you on Desmos that this ordered pair is exactly the same as this ordered pair. So I'm going to go ahead and I'm going to open up Desmos and I'm going to show you some pretty crazy things. So I'm going to put in the ordered pair 2 root 2, oops, 2 root 2, comma, 2, 2. And here's our ordered pair right here. Now, how do we know that that has a radius of 4? Well, let's click on this graph settings, the wrench, and I could change this into a polar coordinate system. And look at this. If I count up my rings, 1, 2, 3, 4, and that falls on the pi over 4 ray. So that's pretty cool. That's just a really quick and easy way to check your work using Desmos. All right, I would like you to try one. So I would like you to convert, maybe I'll type it. I'm a little faster at typing. I would like you to convert 4, comma, 2 pi over 3 into polar coordinates, into rectangular coordinates. Go ahead and pause the video here and try that on your own. Okay, hopefully you had enough time to work on that on your own. Now, we are just going to use this information here. We know that we are starting with r, comma, theta, and we want to go to x, comma, y. So we need to figure out what is x and what is y. Well, x equals r cosine of theta, so 4 cosine of 2 pi over 3. And y equals 4 sine of 2 pi over 3. Now it's a matter of simplifying. So from our unit circle, 2 pi over 3, cosine of 2 pi over 3, is going to be 1/2. So we're going to have x equals 4 times 1/2. So what I did was I replaced this with what I knew was on the unit circle. Now, this is in the second quadrant, and so that 1/2 is actually negative. And so our x value is going to be negative 2. Y is going to be 4 times, well, the sine of 2 pi over 3 from the unit circle is root 3 over 2, which means my y coordinate is going to be 2 root 3. And I could write this as negative 2, comma, 2 root 3. Of course, if I want to check my answer, I can go to Desmos and I could type in negative 2, comma, 2 root 3, and it's right here. And that is 1, 2, 3, 4, and it falls on 2 pi over 3. So I know that I figured that out correctly.